If I ask you to take this simple expression and to expand it out, there's more than one way to do this. One way would be to take the quantity x minus 2, to write it out three times, and then I'm going to take my time here to first FOIL this out, and then I will distribute like so. Let me do that. So you can see that I have FOILed out front, outside, inside, last, and combined like terms. Now I'm going to move ahead, and I'm going to go ahead and distribute the x and the negative. So I've distributed an x to each one of the three terms, and now I'm going to distribute a negative 2. Be careful of your signs. Let's make sure this is going to give me negative 2x squared, positive 8x, and negative 8. Okay, I feel confident what I've done, and now I'm going to go ahead and I'm going to combine like terms. So x to the third minus 6x squared plus 12x minus 8. Okay, I've taken and I've expanded this out, but there's more than one way to do that. And the larger this quantity and the more complex the inside of the parentheses, we may want to revert to an alternative form. Now this is called the binomial expansion theorem, and it's based on Pascal's triangle. If you haven't seen Pascal's triangle, let me introduce it to you now. Pascal's triangle will always start and end with a 1. So this is going to be row 1. Row number 1 is right here. Actually, let me flip this paper around. Okay, so here's how we build Pascal's triangle. It's all based on a pattern. Like I said, we always start with a 1 and end with 1. This is considered row 1. Now when we go on to row 2, again, we start and end with a 1. This second row, we achieve the middle term by looking up above. 1 plus 1 is 2. Okay, so this is row number 2. Let's go on to row number 3. Row number 3, we start and end with a 1. 1 plus 2 is 3. 2 plus 1 is 3. So this is row 4. And we start and end with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 6 plus 1 is 4. I'm going to switch up colors because my black pen is dying on me. Let's go on to row number 5. Start and end with a 1. 1 plus 4 is 5. 10, 10, and 5, and so on. Now, how is that going to help us to achieve this exact same expression when we FOIL it out? So this tells us what row to go to. So I'm going to start by going, this is an alternative to achieving this answer. So I'm going to start by going to row number 3. So row number 3, okay. Row 1, by the way, is after your initial one. So here's row 1. So row 1, 2, and 3. So this is what I want to write down. Got it, okay? I'm going to come back to this. 1, 3, 3, 1. Row 3, because they're expected. So up top is a 3. So 1, 3, 3, 1. Okay, then I'm going to come up top. I'm going to take and think of this as a binomial, two things. So x is one thing, and then instead of thinking this as a negative 2, I want you to capture this as a subtract. Sorry, instead of thinking of subtracting 2, capture it as a negative 2. So behind each of these, I'm going to take the two pieces of the binomial and separate them. The first item, we're going to start with the largest number and we're going to count down. So this is 3, 2, 1, and 0. And then the second term, in this case, the negative 2, I'm going to reverse it. So just like it went 3, 2, 1, 0, it's going to reverse and go 0, 1, 2, and 3. These numbers will always add up to this digit. So 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, and 0 plus 3 is 3. How is that going to help us? Okay, well, any quantity to the 0 power is 1. So this first term is 1x to the third. Now negative 2 to the first power is just negative 2. Negative 2 times 3 is negative 6, and there's an x squared. Negative 2 squared is positive 4. Positive 4 times 3 is 12. Anything to the 0 power is 1. 1 times 1. Now negative 2 times itself 3 times. So negative 2 times negative 2 times negative 2. There is an odd number of negatives, so this final answer is negative, and 2 to the third power is 2 times 2 times 2 is 8. So 1x to the third minus 6x squared plus 12x minus 8. That's exactly what we got up above. All right, let's expand this out. So I'm going to now rely on using Pascal's triangle in order to expand this out. If I did not give that option to you, what you would do is you would take the quantity 2x minus 3 and you'd write it down 5 times, and that just seems like a daunting task to me to go ahead and FOIL this and combine like terms and distribute, and then combine like terms and distribute. That seems like way too much work. So the first thing I'm going to do is I'm going to create Pascal's triangle. So this is row 1, row 2, row 3, row 4, and row 5. Remember, I'm going to go to row 5. Okay, so row 1, I put down my 2 ones. This is row 1, okay? We always start and end with 1. 1 plus 1 is 2, so I've taken care of row 2. Row 3, start and end with a 1. 1 plus 2 is 3, 2 plus 1 is 3. Row 4, start and end with a 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Start and end with a 1. 5, 10, 10, and 5. Here is row 5. How can that help me? Okay, remember the 5th. Okay, so I'm going to write this down, and I'm going to write down each one of these coefficients. Let's see here if I have a nice pen that works. This will work. So I'm going to move this up just a little bit here. I have 1, 5, 10, 10, 5, and 1. Okay, so I'm going to think of each of these as separate. This binomial, I'm going to separate them. So think of it just like this. I have 2x and negative 3, 2x and negative 3, 2x and negative 3. Okay, got it. Now what do I do next? I know that these have to add up to 5. 1, 2, 3, 4, 5. I'm looking this over really quick to see, did I miss something here? Nope, I did not. This is 5, 4, 3, 2, 1, and as a reminder, we will always end and begin with 0. So now when I go back, I have 0, 1, 2, 3, 4, and 5. So to count down your first term, your front will always start with whatever is your number up above, and will always count all the way down to 0. And then your second part of your binomial expression will start with 0 and always count up. When you add these up, they'll add up to 5. 5, 5, 5, 5, and 5. Okay, now this is a little bit more work. If you need to grab a calculator, you can do so. I think a lot of this we can do in our head. Anything to the 0 power is 1. Not 0, it's 1. When I have this quantity to the 5th, I want to remind us what that means. That means this 5 is going to be distributed to the 2 and distributed to the x. So I get x to the 5th. Now 2 to the 5th power. 2 to the 5th power is not 10. It's not 2 times 5. It is 2 times 2 times 2, 5 times. 2 to the 5th power, we can see, is going to be 32. So I have 32 times 1, which is 32. Now let's go to this next part. So I have 5 times 2x to the 4th times negative 3 to the 1st. Okay, well, 5 times negative 3 is negative 15. And 2 to the 4th power should be 16. 2 to the 4th power is 16. And then I have x to the 4th. So negative 15 times 16 is negative 240. So this is negative 240 x to the 4th. I'm going to bring this down. This is 32x to the 5th. Okay, so these are my final answer lies. Okay, so I've taken care of the first two. Let's do the next one. So I know that negative 3 squared, negative 3 times negative 3 is 9, and 9 times 10 is 90. Now I need to take 2x to the third. Well, 2 to the third, 2 times 2 times 2 is 8. So here I'm going to take 8 times 90. 90 times 8 is 720. Okay, negative 3 to the third is negative 27. You can use a calculator if you need to. So I have 10 times some quantity times negative 27. Now this 2 needs to be always distributed to both. 2 to the second is 4, and then I have x squared. So I'm going to take 10 times 4, that's 40. And I'm going to take 40 times negative 27. 40 times negative 27 is negative 1080. Okay, so I've done 1, 2, 3, 4, 1, 2, 3, 4, moving on here. Negative 3 to the fourth power is going to be a positive 81. You can plug that into the calculator if you have to. And then 2 to the first power is simply 2 times x. So I'm going to take 5 times 2 times 81. 5 times 2 is 10, times 81 is 810. Anything to the 0 power is 1. I have 1 times negative 3 to the 5th power, which I believe is a negative 243. All right, here we go. We have expanded it, and I believe that is a lot quicker than taking time here. And remember, with this final exam at the end of the year, it is timed. So it is important to know these shortcut methods. Now let's apply them to another concept now that you are a little more familiar with Pascals. All right, I'm going to work this through 2 problems with you for the very first time. Let's see what we get here. All right, you ready? So we're going to use this idea of binomial expansion. We're using Pascal's triangle in order to take this quantity. So this again would be take 2x minus 3, y, and I would write it out 8 times. Well, there's no way. There's 3, 4, 5, 6, 7, 8. There's no way I want to take time to do all of that. And I want to know, once I've expanded that all the way out, what would be the coefficient that's in front of this term? Okay, so I know that I need to do Pascal's triangle to the 8. So that's the very first thing I'm going to do. Okay, so ready? Here's row 1. Row 2, row 3, 1, 2, 3. This is not row 1, okay? Row 1, 2, 3, row 4, row 5, row 6, I'm just making sure I didn't make a mistake here, and I think I'm in row 6. I think I just made a small mistake. Start with the n, we'll end with the 1. Adds up to 6, adds up to 15, adds up to 20, adds up to 15, adds up to 6. So again, row 1, 2, 3, 4, 5, and 6. Ooh, I was close. Here's row 7. 7, 21, 35, 35, 21, 7, and 1. Just need to put commas here so I can see the difference in the numbers. And now we're on 8. 1, 2, 3, 4, 5, 6. Okay, here's 8. So I have 1 adds up to 8, adds up to 28. I'm going to grab a calculator quick. 21 plus 35 is 56. Adds up to 56. Ooh, that pen is dying on me. 35 and 35 is 70. Adds up to 56. Adds up to 28. Adds up to 8 and 1. This is row 8. You notice the number, by the way. So you can see 1, 2, 3, 4, 5, 6. I mean, hopefully you've noticed, hopefully you've been able to see that pattern and even catch my mistake before I caught it myself. So I don't need to do all of this. If you're thinking, there's no way I want to watch the rest of this video, we are only finding what is the term in front of this. Okay, so I have, there's a 1, I'm leaving my space, 8, 28, 56, 70, 56, 28, 8, and 1. Okay, that's good. Now, pass that up to 8. So remember, we're going to go 8 all the way down to 0. So I'm going to take this binomial, and I'm going to think of it as 2x and a negative 3y. Okay, so this is going to be 2x and negative 3y. Let me put it on pause and quickly write those out. Okay, so now I have each of those terms. Again, we take whatever is the exponent we're given, and this is going to be 8, 7, 6, all the way down, and that very first term of the binomial all the way down to 0. And then I'm going to reverse it and go 0, 1, 2, 3, 4, 5, 6, 7, and 8. Now we want to know with x cubed. So notice that this is going to be x to the 8th, x to the 7th. We want to know x cubed. X cubed is right here. So I'm going to bring this one down. I have 56, 2x to the 3rd, so that's going to be my x cubed, minus 3y to the 5th. So this is going to be y to the 5th. I want x cubed, y to the 5th. Okay, so I want to know what is going to be this final number in front when I know it's going to be x cubed and I know it's going to be y to the 5th. So I need to take 56 in a calculator, giving me myself enough room. Then I need to take 2 to the 3rd. Remember, this has to be applied to both, and negative 3 to the 5th, and negative 3 to the 5th. So that's what I'm going to do in a calculator quickly. I'm going to take 56 times 2 to the 3rd times negative 3 to the 5th. And I end up with an answer of negative 108,864. Negative 108,864.